guys, we are back for chapter 11, I believe. Yep, chapter 11. I got another stuffed animal with me. My daughters keep providing me with stuffed animals. George's Secret Key to the Universe, chapter 11. When he leaped over the threshold of the portal door over back to George and Annie, George found he was floating. Not going up, not going down, just drifting in the huge, great darkness of outer space. He looked back toward the doorway, but the hole in space where it should have been had closed over as though it had never been. There was no way back now, and the giant rock was getting closer all the time. "Hold my hand," Annie shouted to George as he gripped her hand in its space glove even harder. He started to feel as if they were falling down toward the comet, moving faster and faster, as if they were on a giant tilt-a-whirl. George and Annie spiraled toward the huge rock, getting closer and closer all the time. Beneath them, they could see that one side of the comet, the part facing the sun, was brightly lit, but the other side, which the sun's rays didn't reach, was in darkness. Eventually, they landed in a heap on a thick layer of icy, dust-covered rubble. Luckily, they'd come down on the bright side of the comet so they could see what lay around them. "Ha ha ha ha!" Annie was laughing as she picked herself up. She hauled George to his feet and brushed bits of dirty ice and crumbly rock off him. "So," she said, "do you believe me now?" There they are. They're really tiny. You can see them kind of floating towards the comet. "Where are we?" said George, who was so surprised he forgot to be scared. George felt extremely light. He looked around and saw rock, ice, snow, and darkness. It was like standing on a giant dirty snowball someone had thrown into outer space. Stars blazed everywhere, their fiery glow quite different from the twinkling lights he saw from the earth. "We're having an adventure," replied Annie, "on a comet, and it's real. It isn't a made-up story, is it?" "No, it isn't," admitted George. He patted her spacesuit awkwardly. "I'm sorry I didn't believe you, Annie." "That's all right," said Annie generously. "No one ever does. That's why I had to show you. Look, George." She waved an arm around. "You're going to see the planets in the solar system." She started to pull a length of rope out of a pocket in her spacesuit. On the end of the rope was a spike like a tent peg. Using her space boot, she jammed the spike into the ice on the comet's surface. Watching her, George gave a tiny little jump for joy. Even though he was wearing the spacesuit that had seemed very heavy on Earth, he couldn't believe how light he felt. So light that he thought he could leap as high as he wanted. He did another little jump across a little crack on the comet's surface. This time he went up and forward, but he didn't come down again. He seemed to be taking a giant leap, maybe hundreds of feet long. Ooh, you measured with feet last week. You could imagine how many hundreds of feet are. He'd never be able to find Annie again. "Help, help!" George called through the helmet as his jump carried him farther and farther away, his arms whirling around in the surrounding emptiness as he tried to make himself fall down onto the comet. But it was no good. Annie was far away in the distance now. He could only just see her when he looked back. The comet's surface was passing quickly below him. He could see holes and little hills everywhere, but nothing that he could grab onto. But at last, he seemed to fall. The ground was getting closer now, and as he landed, he slid on the ice near the threshold between the bright and the dark side of the comet. In the distance, he saw Annie carefully running toward him. She had to be careful so she didn't float away either. "If you can hear me, don't jump again," she was saying in a very urgent voice. "If you can hear me, don't jump again. If you can—" "I won't," he called back as she reached him. "Don't do that, George," said Annie. You could have landed on the dark side of the comet. I might never have found you. Now, stand up. The boots have small spikes on their soles." She sounded very grown up and not at all like the impish little girl he had met at Eric's house. "A comet is different from the Earth. We weigh much less here than we do there. So when we jump, it can take us a long, long way. This is a different world. Oh, look," she added, changing the subject. "We're just in time." "For what?" asked George. "For that." And he pointed to the other side of the comet. Behind the comet was a tail of ice and dust, which was getting steadily longer. As it grew, it caught the light from the faraway sun and glistened in the wake of the comet, making it look as though thousands of diamonds were shining in outer space. "That's beautiful," whispered George. For a minute, he and Annie just stood there in silence. As George watched the tail grow, he realized it was made up of bits of the bright side of the comet. "The rock's melting," said George in a panic, clutching Annie's arm. "What will happen when there's nothing left?" "Don't worry," Annie shook her head. "We're just getting closer to the sun. The sun slowly warms up the bright side of the comet and the ice turns into gas." Ooh. Seems like you might be learning about that this week as you listen to the videos about water melting, right? And then if you get it really, really hot, it can turn into steam or water vapor. This is actually turning the ice directly into gas, skipping the water part, so it's pretty hot. But it's okay because there's enough ice here for us to pass the sun loads of times. Anyway, the rock under the ice won't melt. So we won't start falling through space, if that's what you're scared of. "I'm not scared," protested George, letting go of her arm very suddenly. "I was just asking." Okay, so we've got two pictures here. One of them is the one I'm just reading about. This one we'll read about in a little bit. "Then ask more interesting questions," said Annie. "Like what?" asked George. "Like, what would happen if some of the rocks from the comet's tail fell on the Earth?" George kicked some dust around and then said reluctantly, "All right, what would happen?" "Now, that is a good question," said Annie, sounding pleased. "The rocks catch fire when they enter the Earth's atmosphere. And from the ground, when we look up, they become what we call shooting stars, or meteors." They stood and gazed until the comet's tail got so long they couldn't see the end of it. But as they were watching it, the comet seemed to start changing direction. All the stars in the background were moving. "What's happening?" George asked. "Quick," Annie replied. "We've only got a few seconds. Sit down, George." She cleared two little spaces on the ice, speedily brushing the powder aside with her glove. Reaching into another pocket of her suit, she produced what looked like climbing hooks. "Sit down," she ordered again. She screwed the hooks into the ground and then fastened them onto a longish piece of cord hanging from a buckle on George's suit. "Just in case something hits you," she added. "Like what?" asked George. "Well, I don't know. My dad normally does this part," she replied. Next, she sat down behind George and did the same to herself. "Do you like roller coasters?" she asked him. "I don't know," said George, who had never been on one. "Well, you're about to find out," said Annie, laughing. The comet was definitely falling, or at least changing direction toward what seemed to be down. Okay, so you have to look really closely at this picture. The two of them are sitting right here, fastened onto the comet, and you can see all the ice. From the way the stars were moving all around them, George understood that the comet was falling very fast, but he couldn't feel anything. He didn't have butterflies in his stomach, and there was no rush of air blowing past him. It wasn't at all how he had expected a ride on a roller coaster to feel, but he was starting to realize that things feel very different in outer space from the way they do on Earth. George closed his eyes for a moment just to see if he could feel anything at all. But no, nothing. Suddenly, with his eyes closed, he realized that something in space must be pulling them and the comet toward it for the comet to change direction like that. George instinctively knew that this probably much, much bigger than the comet on which he and Annie were surfing through outer space. So that thing that's pulling, we talked about that would have gravity and would pull it towards it. All right, that's the end of the chapter, but if we go back to page 99, there's a little part about mass. Mass is a hard word to understand sometimes, but we'll see what we can get from it. It's a little bit different than weight, but it involves weight. The mass of a body measures the force, so the effort, needed to move it or to change the way it moves. Mass is often measured by weighing the body, but mass and weight are not the same. The weight of an object is the force attracting it to another object. That's how we get our weight, is because of the gravity of the earth pulling it towards attracting it. Such as the earth or the moon, and it depends on the mass of both objects and the distance between them. You weigh slightly less on top of a mountain because you are farther from the center of the earth. In the dark box it says, because the mass of the moon is much less than the mass of the earth, so we're looking at its whole space, the amount of space it takes up and the amount it weighs. An astronaut who weighs about 200 pounds on Earth would only weigh about 33 pounds on the moon. So if you weigh 100 pounds, you're maybe only weighing like 16 pounds on the moon. So those of you who weigh 50 pounds, now you're going down to probably about 7 or 8 pounds on the moon. So you wouldn't weigh very much. So astronauts on the moon could, with the correct training, beat any Earth-based long jump record. So they could jump farther because they don't weigh as much. The next little circle says, Einstein was a German physicist who was born in 1879. He discovered that energy is equal to mass according to the famous equation E equals mc squared, where E is energy, m is mass, and c is the speed of light. So the amount of mass times the speed of light would give you the energy. Speed of light squared, which means you multiply the speed of light times itself. So it becomes a very big number. Because the speed of light is very large, Einstein and others realized that this equation suggested one could make an atom bomb in which a small amount of mass is converted into a very large amount of energy in an explosion. The last one says, Einstein also discovered that mass and energy curve space, creating gravity. So mass and energy is where we get our gravity. Okay, so then turn to the last page of the chapter, page 104, and we'll talk about comets. So the first comet says, comets are big, dirty, and not very round snowballs that travel around the sun. They are made up of elements created in stars that exploded a long time before our sun was born. It is believed that there are more than 100 billion of them, very far away from the sun, waiting to come closer to us. But we can see them only when they come close enough to the sun to have a shiny tail. We actually have seen only about 1,000 comets so far. The second comet says, the largest known comets have a central core of more than 20 miles from one side to the other. So that's pretty big. We're going 20 miles. That would be 80 times around the track in one big line. When comets come close to the sun, the ice in them turns into gas and releases the dust that was trapped inside. So kind of like when you melt a snowball, but there was dirt inside, right? This dust is probably the oldest dust there is throughout the solar system. It contains clues about our cosmic neighborhood at the very beginning of life of all the planets more than 6 billion years ago. In the dark box, it says, most of the time, comets circle around the sun from very far away, much, much farther away than the Earth. Every now and then, one of them starts to travel toward the sun. There are then two possibilities. One, some, like Halley's Comet, will get trapped by the sun's gravity, and these comets will then keep orbiting the sun until they melt completely or until they hit a planet. Halley's Comet's core is about 9.6 miles. So almost 10 miles, it would be 40 maybe 36 miles or 36 times around the track. It returns near enough to the sun to melt down a bit and have a tail that can be seen by us about every 76 years, so once in everybody's lifetime almost. It was near us in 1986 and will be back in 2061, so it'll be something to remember so you can watch for it. Some of the comets trapped by the sun's gravity return near the sun much more rarely, so not as often. The Hyakutake comet, for instance, will travel for 110,000 years before coming back. Number 2, the other option is because they have too much speed or because they do not travel close enough to the sun, some other comets, like Comet Swan, never come back. They pass by us once and then start an immense journey in outer space toward another star. These comets are cosmic wanderers. Their interstellar journey, so interstellar between the stars, between the things in the solar system, can take hundreds of thousands of years, sometimes less, sometimes even more. All right, so that is the end of chapter 11. See you next time.